Chapter 7, we are going to move on to the rational expression and equations. This is actually not very new to us because what we have done in pre-algebra, we learned a lot how to deal with fractional number. And now we are going to move on to a new expression. So it still has a numerator and a denominator, which means we have a bar here. But the numerator and denominator, this numerator, will not be a number anymore. So this is a typical fraction number. Now, if we replace the numerator and denominator by what? By the algebraic expressions. We do not have just integers there. We might have 4x minus 1. That is the numerator. And denominator is what? Is 5x squared plus 2x minus 6. So I just make this up. This is called the rational expression. The rational expression always have a numerator and denominator. And the fraction number is actually a special rational expression. What we have learned before, all the math rules can be applied on the fraction number. They can all be applied to the rational expression. So what we are going to do today, we are going to start the some fundamental things about like review. We start from the fractional number and then apply those rules onto rational expression. So the first one we are going to do today, we know what? So we know if I give you one fraction number like this, 4/0, can you simplify what that is equal to? The fraction number can also be seen as a division here. So 4/0 means 4 divided by 0. And we all know that we can never divide a number by 0. Or in another word, for a fractional number, 0 can never be a denominator. If we do see 0 on the denominator, what do? We just write down this one. So this number is undefined. Get used to this word, undefined. Undefined means it means does not exist, does not make sense, and this number does not exist at all. And this number we always see this, the mathematical terminology is called undefined. So when the denominator of a fraction number is 0, this number is actually undefined. Now we apply this to the rational expression here. When we have one expression, I will give you a simple one like 4/n minus 3. This one has a numerator. The numerator is just one integer here. And the denominator is one polynomial, a binomial, or we just see it's one algebraic expression. So this one looks fine now, okay, because n can be any number. So this is one algebraic expression here. No, this is one rational expression. Now we are asked, please find the value for n to make this expression undefined. So n can be any number, but one number will make this rational expression undefined. Can you find this number? Or let's read this. So the first typical problem will be identify values for which a rational expression is undefined. So if we are given one rational expression, we want to find out what value for that variable will make this rational expression undefined. What do? We know when the denominator is 0, then this expression will be undefined. So n just let the denominator be 0. So n minus 3 be 0. Can we solve for n? Algebra 1 problem, linear equation. We add 3 on both sides. We got n equals 3. So now we can answer. When n equals 3, this rational expression is undefined. So to solve all those type of problem, we always let the denominator be 0 and then solve for the unknown here. Practice. I'll give you a few problems to practice here. So let me start. The first few are pretty simple. Now let's look at number 4. So the problem is identify the values for which the given rational expression is undefined. So if this expression is undefined, what do? We just let the denominator be 0. So 2 times c equals 0. Now can we solve for c? Follow the rule. 2 times c equals 0. To get c, we're going to divide by 2 on both sides. 2 divided by 2, that's 1. 1 times c is c, so those two cancel out. On the right side, we have 0 divided by 2. Okay, 0 divided by 2 equals what? Equals 0. Again, do not confuse those two things. So 0 divided by 2, that makes sense, okay? It's actually 0 divided by any non-zero number is always 0. Does not matter. The number is big, small, positive, negative, does not matter. As long as this is not 0, 0 divided by another number is always 0. But when we flip those two numbers, 2 divided by 0 equals what? Equals undefined. Okay. I cannot stress more how important this two division are. We use them, almost everywhere, every topic, every expression. We will be using those two rules. I'll go back here, very simple. We got c equals 0. Now we can answer. When c is 0, this rational expression is undefined. Another one, number 5, follow the same thing. To make this rational expression be undefined, we just let the denominator n squared minus n minus 2 equals 0. Now we need to look for what n is. What problem do we have now? We go back to chapter 6. In chapter 6, we learned how to solve this equation. So this denominator equals 0 turns into a quadratic equation. We have one unknown. We have the square term. This is called a quadratic equation. How do we solve quadratic equation? We write it as a standard form, which means we see 0 on the right and put all terms in order. So this is actually a standard form already. Now we are going to factor the left side. We have a trinomial. The leading coefficient is 1. Then we just factor it into 2 binomials. I have n here and I have n here. I just need to find the 2 numbers. Their product is -2 and their sum is -1. So quickly go through all the possibilities. What 2 numbers? Their product is -2. 1, 2. One of them is negative. If their sum is -1, so that means 2 should be negative, 1 should be positive. So +1 and -2 are the 2 numbers which satisfy the 2 conditions. Product is -2, sum is -1, and then equals 0. See, this is what we learned in chapter 6. If we don't know how to do the factorization, we cannot solve this problem. Okay, then the product equals 0, then let each one be 0. This one equals 0, or the second binomial be 0. N plus 1 equals 0, what do we get? N equals -1. And or, okay, n minus 2 equals 0, what do we get? N equals 2. So that means 2 numbers can make this rational expression be undefined. two answers here. Another quick review. Okay, so to find this, the number make this rational expression be undefined, we let the denominator, whatever the denominator is, let it be 0, and then solve for it. This is a special quadratic equation. On the left, we have a binomial, and this binomial term happens to be the difference of squares because 4 is 2 squared. Okay, so then we factor 8. Squares minus squares, we got x plus 2. Sum of the two bases times subtract the difference of the two bases equals 0. And then again, let each one be 0. I will get x equals -2 or x equals +2. And this will be the first type of problem you will see on the assignment and in the coming midterm, or maybe in the coming final exam. So you will, this is one very, very typical problem we'll see in chapter 7. Find the values to make the rational expression undefined, which means the denominator is 0. Okay, so this is the first thing we get from the rational number. Now let's go back to it. So for all rational number, and there is another thing here. So we want to know whether or not the two fraction numbers are equivalent or not. So we have 1/3. This is one fraction number. And we have another one, 4/12. Okay, so we want to know, are those two fraction numbers equivalent? Are they equal to each other or not? Are they equivalent? To find, so there is a quick way to determine any two fraction numbers are equivalent or not. If you remember that, you know, if we have two equivalent fraction number, then if we multiply, if we do the cross multiplication, diagonal, okay, multiplication, the product should be the same. So two equivalent fraction numbers, their cross product means multiply this way, diagonally. Their cross product should be the same. So now let's verify. 1 times 2 equals, no, 1 times 12 equals 12. And then do the other cross product. 3 times 4 equals 12 again. And 12 are equivalent. Therefore, I can make the conclusion. So 1/3 does equal to 4/12. This is what we did for fraction number. Now we can apply the rule to the rational expression to determine. So the second problem, what we'll see here will be determine whether rational expressions are equivalent or not. So they does not look the same, but they might be identical. And how do we do this? Now let's look at a problem here. Okay, see what I have here. Okay, I have this problem. Indicate whether each pair of rational expression is equivalent. Okay, so let's do the first one. It doesn't look very simple. All right, so now let's see, what do we do? Just do the cross multiplication here. I do, so 7x plus 5 times x squared minus 3. What is their product? What do we do? Go back to Algebra 1. When we multiply any two binomials, we follow the FOIL rule, F-O-I-L. Okay, so first times first, 7x times x squared, 7x to the third. So you could do the mind calculation at this level now. So 7x times x squared, that is 7x to the third. Oh, outer, 7x times negative 3, negative 21x. And then I, inner, 5 times x squared, 5x squared. L, last, 5 times 3, negative 15. After you have this product here, the best way is what? To rewrite it in the descending order. Okay, I have 7x third. Then the second term should be the square term, plus 5x squared. Then the x term, minus 21x minus 15. So that will be their product, the first cross product. Then I cross multiply the other two. What I have here, I have x minus 3 times 7x squared plus 5. Apply the FOIL rule again. First times first, 7x third. Oh, outer, 5 times x plus 5x. I, inner, 3 times 7, negative 21x squared. Last, 3 times 5, 15, negative 15. And again, this is also not in order yet. We are going to sort all the terms, 7x third, and then minus 21x squared plus 5x minus 15. Now we are going to compare. Are those two products equivalent or not? Just compare term by term. First term, the same. Second term, no, they do not have the same coefficient. Third term, still different. Last one, the same. But as long as there is a little bit of one difference, those two products, they are not identical. So we can answer, are those two equivalent or not? So no, the answer will be no, they are not equivalent. So we can make the conclusion here. All right, so this is one. There is another one, same problem. So if we determine whether or not those two are equivalent or not, they do not look the same. But when we cross multiply, we find out they're actually identical. They're cross product. Then we'll see those two expressions are equivalent. So get to know these equivalent expressions. So this is the second one, very, very typical. There is no tip, just follow the rule. Cross products are equivalent, then the two expressions are equivalent. There is no trick. No, there is no trick at all. The third thing, okay, and again, we go back to the fraction number. So we all know that whenever we have a fraction number, we have to guarantee if we want to write this as a final answer, we have to make sure this fraction number is a simplified or reduced fraction number. We can never leave, for example, the number on the 4 over 12 as the final answer. This is a fraction number, but we cannot leave it there. We have to simplify this. How do we simplify the fraction number? And we know both the numerator and denominator are the product of 4. So 4 equals 4 times 1. 12 equals 4 times 3. Then 4, we can divide the numerator and denominator by 4. So 4 divided by 4 or 4 divided by 4. Or we can also see, we can cancel the two same factors on the numerator and denominator. In other words, whenever you see the same factor, so I have to stress what I just said here. Factor means part of multiplication. So factor is a number next to the operator of this one, okay? And 4 times x, 4 times 3, 4 is a factor. We can cancel the same factor on the numerator and denominator. So 4 divided by 4 is 1. So those two cancel each other. What is left? 1 and 3. So 1/3 is a simplified form for 4 over 12. This is what we did for fraction number. For rational expression, we do the same thing. For example, if I have this one, okay, if I have 5x over 12x. This is the numerator. This is the denominator. 5 times x means 5x. 12x means 12 times x. Now we want to see, can we simplify this rational expression? Can we? Yes. Why? Because both the numerator and denominator have a factor x. So this x and this x, those two are identical. They're both factors. Therefore, those two factors can cancel each other. I will have 5 over 12 left. Okay, and 5, 12, there is nothing in common. Then those two numbers stay like this. But alert, a very, very common mistake, that why I had to write down the word factor here. Another typical problem, very common mistake. If I give you one expression like this, 5 plus x over 12 plus x. This is still a rational expression. And some students say, oh, I see x on the top, I see x on the bottom. And the same number could cancel each other. So when I cancel this x and this x here, I will have 5 left on the top and 12 left on the bottom. And this is my answer. And remember, this is completely wrong. This is wrong, okay? And this is not right. Wrong. You cannot do this. Why? Because this x is adding 5. This x is adding 12. And those two x's, they are not factors. They're actually called addends. And we can never cancel addends. We can only cancel factors. So those two x's, they have to stay there. So can we, the problem, 5 plus x over 12 plus x, can we simplify this one? The answer is no. This rational expression is in a simplified form already. We cannot continue to simplify it. Final answer. It just leave like that. There is no more simplified form anymore. This is the final one. So compare those two problems. Do not cancel those. We can only cancel factors. Okay, we can only cancel factors. We cannot cancel addends. This is the second one. The third one, sometimes they'll say, okay, Professor, you just said I cannot cancel factors. All right, let me grab another piece of paper right here. So for example, I give you another one. X squared minus 1 over what? Over x squared plus 2x plus 1. So what I have now, I have a rational expression. And you'll say, okay, both the numerator and denominator, they are polynomial. Okay, there is no factors at all. So I cannot simplify this. There is no. Okay, so whenever we try to simplify, do not just look at the given, the original form. We need to see, can we factor? So because the numerator itself is a binomial, is a polynomial. The denominator is another polynomial. Before we make decision, oh, there is nothing in common, we have to see, can we factor both of them respectively? So by looking them now, there is no common factor because there is no factor at all. And to check whether or not are they able to be simplified, we are going to look at the numerator respectively. So forget about denominator. Just look at numerator. X squared minus 1. Can we factor this numerator? Can we factor this binomial? Typical binomial. Difference of squared, because 1 can always be seen 1 squared. So numerator is the difference of squares. Can we factor 8? Absolutely. Add the two bases and then subtract the two bases. X plus 1 over x minus 1. Then we just look at the denominator. X squared plus 2x plus 1. For this trinomial, leading coefficient is 1. So we're going to look for two numbers. What two numbers? Their product is 1, their sum is 2, 1 and 1. So then this can be factored as x plus 1 times x plus 1. So step 1, we don't do anything else, just try to factor the numerator and denominator. If they cannot be factored, and then it stays like that. Now we are going to compare. Do we see any common factors? Common means same. Do they have any factor in common? Common means part of multiplication. This means multiplication right here. Well, see, I have x plus 1 here. I have another x plus 1. Those two binomial, they're identical. They're common factors. They can cancel each other. And then we'll have the other. Are they identical? No. Another thing I want to learn from, one factor can only cancel just one factor. You do not see, I have x plus 1 here. I have x plus 1. Oh, I have another x plus 1. This one can also be canceled by the top x plus 1. No, one can only cancel one factor. Okay, and this one has to be left. Then the final answer will be what? X plus 1, no, sorry, x minus 1 over x plus 1. Final answer. Do not ever try to simplify this cross those two. So those two x's, they cannot cancel each other. Why? Because they are not factors here. And this will be the final answer. So now let's sort. So if we are given a problem, very, very typical one. We are given one rational expression. We are asked to simplify a rational expression. What do we do? Two steps. Step 1, factor the numerator, denominator respectively. Step 2, do the cancellation. Cancel the common factors. If there are any, cancel them. If there is no, leave them. Leave everything there. Okay, so this is very, very important topic about rational expression. It's the same thing as for from now on till the end of chapter 7. Whenever we reach the final answer, so pretty soon we'll learn how to multiply, how to divide, how to add, how to subtract the rational expression. The final answer has to be a simplified rational expression. So when we stop, or before we stop, we have to check, can we simplify the rational expression or not? Okay, so this is the third thing we learned today, how to simplify the rational expression. Let me just quickly give you one more example here. Okay, and let's look at number 12, this problem here. What do we have? We have numerator, denominator. And remember, when we factor, okay, and never do this. So you do not see y squared, cross out this y squared, this y, cross this y. You cannot do this because this y squared is not a factor of the numerator. This y squared is not a factor of the denominator. So we cannot cancel them out. What do we do? Follow the rule. Step 1, factor. Can we factor the numerator? When we do the factorization, what do we do first? Always check the GCF. And again, what we are doing in chapter 7, we kind of are reviewing chapter 6. How do we do the factorization? Okay, always check the GCF first. 3y squared, 12y. Do they have anything in common? I see 3y is a common factor. Okay, and then write down the leftover in the parentheses. What do we have? We have 3y squared over 3y. I have a y left. 12y over 3y equals 4. This is factor the numerator. Then move on to the denominator. 6 and 21. Do they have anything common? 3. Then I have y squared, y here. I have a common variable y. 3y is also a common factor. Find the GCF out, and then the leftover will be 2y plus 7. Okay, the next step is the simplest one. Just do the cancellation. 3y, 3y, cancel each other. And this entire parenthesis is a factor. Y itself, inside of this is not a factor. So this parenthesis, the whole thing in the parenthesis is multiplying something else. So that will be a factor. And this is another factor. Are those two factors identical? No, they're not the same. So then those two factors stays. I have y plus 4 left on the top, 2y plus 7 left on the top. And on the bottom, final answer. That's it. So all typical problem we see in chapter 7. Try to simplify a rational expression. 2 steps process. Step 1, factor the numerator denominator respectively. Step 2, cancel the common factors, and then write down the leftover final answer. This is another exam. Let me see. Do I have? I think that's pretty. That's it. Maybe just give you one more. Yeah, when we are doing this here, is kind of reviewing the factoring problem. So what I have here, I will give you this one, number 19, is reviewing the factorization. So I want to simplify this rational expression. I will look at the numerator and denominator respectively. And so when I try to factor the numerator, you cannot think of the factor form. I cannot do that. I have to try. So my scrap paper, okay, so suppose this is my scrap paper here. I write down this trinomial. What does this equal to? So to factor this, I'm supposed to be able to get 2 binomials. And I have checked, there is no common fact, no GCF. And then I will have to look for 4 numbers. The first 2 numbers, their product should be 6. So I can either use 1 times 6 or 2 times 3. So let me just try. I use 2 times 3 first. Okay, and then to get number -6, I will 2 times 3, that's 6. And so if I get the 2 here, 3 here, cross multiply, get the 6 cannot give me a 5. But if I switch them, I put 3 here, 2 here. When I cross multiply, 3 gives me a 9, 2 times 2 gives a 4. 9 and 4, they can get a number 5 if they have the right symbol. They have the right sign. Okay, so don't forget, I have -6. So 2 and 3, one of them should be negative. Which number should be negative? I will give number 2 here. Why? Because when I cross multiply, 2 times -2, that's -4. 3 times 3, that's 9. -4 plus 9 give me a +5. So I did, even though, so don't look at, I'm not lucky to write down those 4 numbers in this way. I did a lot of screening in my mind. All right, I tried, and I just look for the largest possibility. So what if I use 1/6? You see, no matter how hard you try another 1/6 2, 3, you can never get number 5. So then I just choose the, maybe 2 and 3 has a larger possibility. And so it needs some experience to get the combination quickly. I have practiced a lot. That's why I can make this happen. Don't be afraid. Professor, I cannot find this. I had to go through. Yeah, take your time. Go through all the other combination. You'll find none of them is working. When you reach this combination, finally it works. And you can stop now. So those 4 numbers are the 4 numbers you're looking for, and put them into 2 binomials. I will write here. The 2 and 3 means 2x plus 3. 3 and negative 2 means 3x minus 2. That's the numerator. Denominator, I have 6x squared minus 19x plus 10. And again, no GCF. And what I'm going to do, I don't know, maybe I just try 2 and 3 first. And then to get number 10, I can either use 1 times 10 or 2 times 5. If I put, let's see, 2 here, 5 here, I will 5, 2, that's 6, 5, that's 16. Okay, 10, 6 cannot give me 19. If I get 1, 10, there is no way to get 19 either. If I have 5 here, 2 here, when I cross multiply, what do I get? Number 15 and number 4. 15 and 4, they can get 19. Okay, so I did a lot of pre-screening here. I end up with the arrangement. Then to get a negative 19, I should give 2 negative signs to both of 2 numbers, because negative turns into positive. Now double check. So did I get the right combination? 2 times negative 2, negative 4. 3 times negative 5, negative 15. Negative 4 plus negative 15, what does this equal to? Negative 19. That's exactly the middle term here. All done. Okay, this is very, very challenging. You cannot just write down the factor form right away. You have to do a lot of work, trial, test. Then you can get the those 2 numbers. Give me binomial 2x minus 5. 3 and negative 2 means 3x minus 2. So fact, the numerator, denominator, respectively. The next step, just use your eyes and check. Do you see anything in common? 3x minus 2, 3x minus 2. They are identical. They cancel each other. And the other 2, they're not the same. They stay. Then the final answer will be 2x plus 3 over 2x minus 5. Final answer. This is a simplified version of this rational expression. All right, so this is section 7.1. What I'm going to do, I'm going to quickly stop the recording.